So next, let's take a look at this example problem. We have a 3-meter rod which pivots about its left end. A force of 6 newtons is applied perpendicular to the rod at 1.2 meters from the pivot, causing a counterclockwise torque. And a force of 5.2 newtons is applied at the end of the rod opposite the pivot. The 5.2 Newton force is at an angle of 30 degrees to the rod and causes a clockwise torque. What is the net torque on the pivot? So to solve this problem, the first thing we'll need to do is draw a picture showing all of the forces on this rod and their directions. So first off, here is the rod. And we know that this rod pivots about its left end. So that means I'm going to put the origin here at the pivot point. Then we have two forces, and one of the forces acts at a distance of 1.2 meters from the pivot. So that means our moment arm is going to have a length of 1.2 meters, and I'll call this R1. And then the force is perpendicular to the rod and would cause a counterclockwise torque. So that means the rod would swing in the counterclockwise direction if only this force was applied. So that must mean that the force is in this direction. It's perpendicular to the rod, and it would cause the rod to swing in a counterclockwise direction. So I'll call this F1, and this has a magnitude of 6 newtons. Then there is a second force which is applied to the very end of the rod, and it is applied at an angle of 30 degrees to the rod. So that means that if I continued my rod along, this second force is with an angle of 30 degrees with respect to this line. Now this force causes a clockwise torque, which means it would make the rod swing down this way. And so that must mean that the force is angled like this. So it's 30 degrees with respect to the direction of the rod, and it's going to cause a clockwise torque. Now this second force, which I'll call F2, has a magnitude of 5.2 newtons. And its moment arm, which gives us the distance from the origin to where the force is applied, is going to be equal to the total length of the rod, which is 3 meters. So I will draw a second moment arm, and this R2 is 3 meters. So we want to find the net torque on the pivot. We need to add up these two torques. So the sum of the torques is going to be equal to the sum of the torques caused by these two forces. So if I concentrate first on the F1 force, then that's going to be equal to R1 times F1 times the sine of the angle between them. But the angle is 90 degrees. The force is perpendicular to the moment arm, and the sine of 90 is equal to 1. So I can just leave that off because I know I'm just multiplying these two numbers by 1. Then I also have to think about the sine of this torque. So this force alone causes the rod to rotate in a counterclockwise fashion, and that means that this is a positive torque. So this torque is positive. I don't need a negative sign for this particular torque. So then let's focus on this second force. So I have the moment arm R2 times F2 times the sine of the angle between the moment arm direction and the force direction, which is 30 degrees. Now this force, if it's the only one applied to the rod, would cause the rod to rotate in the clockwise direction, which means this is a negative torque, so I need to include the minus sign. So at this point, I think I'm ready to plug in numbers. R1 is 1.2 meters long. The amount of force is 6 newtons, minus R2 is 3 meters long. The amount of force is 5.2 newtons, and then I multiply by the sine of 30 degrees. So if I multiply those together and add them up, I'm going to get a net torque of negative 0.6 newtons times meters. So that would be the value of the net torque. It indicates that this second force is which is the causing the negative torque, is going to cause a bigger torque than this force, and so overall the rod will tend to rotate in the clockwise direction.